In this video, we are going to go over the concepts of Lab 1, which is titled Chemistry Lab Techniques and Separations of a Mixture. As you can see in the purpose, this experiment examines how to operate the laboratory Bunsen burner, how to bend glass, and in addition, students will be separating a mixture using physical properties. Let's proceed now to talk about the background for this week's lab. The first thing that we need to talk about is laboratory equipment. So understand that in many labs, it could be biology, it could be chemistry, you will encounter some basic equipment. And in figure 1, you can see many of the common laboratory equipments that you will be observing this semester virtually. As you can see in the top left corner, which I'm highlighting by underlining in green, you can see an illustration of a Bunsen burner. Many of the laboratory equipment that you see here are going to be utilized for different purposes. So that's why we're going to proceed to the second page of this lab sheet to understand the descriptions for some of these important laboratory equipment. The first one that we are going to go over is a beaker. Okay, and if I go back to the first page, the beaker is right here in the top right corner. A beaker is a common container in most labs. Understand that we use it for mixing, we use it for stirring, and sometimes when we need to heat some chemicals, we also utilize it. Now, understand that because this specific laboratory equipment has spout on their rims, it makes it easier for them to be utilized for pouring. The next one that we are going to talk about is an Erlenmeyer flask. And if we go to the first page, here we have an Erlenmeyer flask. An Erlenmeyer flask has a narrow neck and it expands towards its base. This allows this type of glassware, because it's made out of glass, being utilized for mixing and swirling without having much risk for spilling the content of the chemicals that have been put in it. The next type that we have is a rubber stopper. And understand that here we have assorted rubber stoppers. And if you're utilizing rubber stoppers, understand that it depends on the purpose of what you're going to use them for, okay? Because these rubber stoppers, they can actually be utilized to cap certain types of glassware, depending if you're going to utilize them for mixing, or if they have holes. As you can see, there are some that have holes, is because they could be utilized in order to create vacuum systems for the lab. Next, we have a test tube. And the test tubes are right here. And test tubes are a glass tube that has one end open and then the other end is closed. We typically utilize them to hold small samples. Those test tubes, because of their shape, they cannot stand by themselves. So that's why we utilize a test tube rack. And that specifically is designed for holding them. Next, we have a watch glass. And as we look throughout this illustration, it is under the Erlenmeyer flask. The watch glass, as you can see, is a round piece of glass that is slightly concave, okay? So it kind of looks like a lens, and it is utilized to hold a small amount of liquid or solid. The next instrument that we're going to talk about is a lab funnel. And you can see the funnel right here next to the test tube rack. And the lab funnel is just like any other funnel, except that it was designed to be used in the laboratory setting. Sometimes they're made out of glass, sometimes they're made out of plastic, but understand that pretty much we use it in order to dispense correctly a liquid into a glass container or a container that we're using in the laboratory. The next equipment that we have is graduated cylinders. And you can see the graduated cylinder right here. And as you can see, a graduated cylinder is the primary measuring tool for the volume of liquid in a laboratory. To dispense liquids, we also have droppers and micropipettes. And you can see them here close to the funnel. We have a dropper and we also have the micropipettes. And as you can see, they could be made out of glass, they could be made out of plastic. They have a narrow tip and they have a bulb, okay? And basically you can suck liquid into them. Some of them actually have markings so you know what kind of volume you're able to dispense. But they are utilized just to obtain some liquid and to just pour it into a reaction if it's necessary. The next equipment that we have is a ring stand. Here close to the Bunsen burner. And that ring stand is used to suspend beakers, flasks, or anything else that you need to suspend, depending on the experiment that you're doing. And in some cases, you can actually utilize a heating source, okay, like a Bunsen burner, when you're utilizing a ring stand in order to heat up a substance. Whenever you're heating up a substance, remember that elevation, or to create the space to be heating the substance that you're interested in, you may use a wire gauze with an iron ring. And they're right here. Iron ring and wire gauze. And the iron ring will be connected to that vertical line or that vertical tube that you can see in the ring stand, and the wire gauze sits on top of the iron ring. We also have utility clamps, and you will see in the virtual videos that sometimes they can also be utilized for example, filtration systems. That is just another way in which things can be suspended in the laboratory. In the lab, we also have tongs and forceps. And these specific instruments, which you can see here, here are the forceps, here are the tongs. And forceps, to be honest with you, is just a fancy word for tweezers. But tongs and forceps are utilized for grabbing things that shouldn't be touched by hand. So for example, if you have a hot glassware that you need to move, or if you have a cold or hot substance that you need to transport, sometimes you utilize them in order to move the container where you have it, which it could be a beaker, it could be Erlenmeyer flask. Next, we have spatulas and scupulas. And you can see a scupula here next to the wire gauze. And spatulas and scupulas, as you can see, is to scoop solid chemicals whenever you need to utilize them in the laboratory. We utilize a thermometer for measuring temperature, okay, of liquids. And if you go to figure 1, you can see the thermometer here next to the graduated cylinder. Lastly, we have here a balance, and as you can see, it's not illustrated in figure 1, but a balance is what is utilized specifically in order to measure the mass of solids that are utilized in the laboratory. Next, on page 3, we have a discussion for the Bunsen burner. So, a Bunsen burner, which you can see illustrated in figure 2, is one of the most efficient ways in which we can heat materials in the laboratory as long as the substance that we're heating is not flammable. Okay, so these Bunsen burners, they come in a variety of designs, but most operate with the same principle, which is mixing gas with air in order to produce a hot flame. Now, understand that whenever we are operating a Bunsen burner, we are going to have specifically the air control vent, which is where the air is going to come in. The barrel is what's going to allow more or less air to come into the Bunsen burner. Understand that when a Bunsen burner it is utilized, the hottest flame that you can create is going to be called a non-luminous flame, which is actually blue. And this non-luminous flame, understand that it has an outer and an inner flame. This is going to be better illustrated in the YouTube video that you guys have to see as part of the experiment that you guys are going to be performing. Now, as you can see, after the illustration of the Bunsen burner and the parts of the Bunsen burner, which you need to be familiar with them, there are paragraphs talking about how to correctly heat objects in the laboratory. Okay, and when we're heating objects strongly, you always place them at the top of the inner cone, which again, the inner cone is where the hottest part of the flame is. So your non-luminous flame is going to have an inner cone and an outer cone, but the top of the inner cone, which is the hottest part of the flame, that's where we heat objects. Okay, now understand that whenever you're heating objects, you want to do that slowly and evenly. Okay, so you have to stir the content of the container whenever you have that possible. Okay, and specifically, you will be observing also in a YouTube video that when you're bending glass, you have to rotate that glass, okay, back and forth in the flame in order to do that bending action on the glass. Let's move on to talk about dispensing substances. Whenever we're dispensing substances in the laboratory, we have solid and we have liquid substances that we're going to be dispensing. So understand that whenever you're dispensing solids, because they are stored in bottles that at times have screw caps or they have a stopper, understand that before you dispense that solid chemical from that bottle or container, you must rotate it gently, and you need to tap it gently also in case the substance is actually clumped together. Then you're going to remove that cover and then you're going to place it in one hand. You're going to remove the desired amount of that solid with a clean and dry spatula. Now, if you remove too much solid, please don't put it back into the original container, because the issue is that then contamination can happen in that sample. When we are dispensing a liquid chemical, understand that specifically, if you have a bottle that contains a stopper, when you open it, you're going to be placing that stopper in between your fingers to hold it correctly. Then you're going to place that bottle in the same hand that you have the stopper. You can tilt it a little bit depending on the amount of liquid that you have in there, okay? And remember, you're going to have one of the apparatuses. You could be using, maybe pouring into a graduated cylinder. You could be using a pipette. You could be using a dropper. But the main thing is that once you remove the liquid, the excess, if you took too much of that compound, please do not return to the bottle, because that is a source of contamination. Then on page 4, there is a discussion about the classification of matter. Understand that by definition, matter is anything that has mass and occupies space. And it can be classified as, depending on its composition, as a pure substance or as a mixture. Now, pure substances are going to be those elements that are in the periodic table, and whenever those elements combine together, they form a compound. Remember, a compound is going to have those elements chemically linked to one another, and we are going to explore the different type of bonds later in the semester. Now, when it comes to a mixture, remember, a mixture is 2 or more substances that are physically combined, but they're not chemically combined. They have to be physically mixed, okay? So when that happens, understand that if you have a mixture, they can be separated by physical methods, which is what you will be exploring in the second part of this week's lab. Now, in the last paragraph of page 4, we have a discussion between chemical and physical changes, which is just telling you what are the differences between those changes that matters can undergo. When it comes to physical changes, understand that physical changes are not going to change the composition of the substance that you're studying, while chemical changes, because it is the interaction of your original substance with other substances, will result in the formation of a brand new compound. And because we have a brand new compound, then we have a new identity for that substance that results from that chemical change. So in this lab, as I mentioned, we are going to be separating a mixture, and this mixture can be separated through different techniques. Now, even though we have here a set number of techniques, understand that in this week's lab, we are only going to be performing filtration, sublimation, and evaporation. Okay? So make sure that on page 5, you read through each one of the different techniques. You're familiar with the definition, but understand that only filtration, which is the process of removing or straining a solid, okay, from a liquid substance using a filtered paper or porous material, will be done in this lab. We're also going to be performing sublimation, which is a physical property of some substances that are going to be changing a state from solid to gas. And once that gas cools down, you can obtain that substance again as a solid. And lastly, we have evaporation, which is a technique that is used to separate out homogeneous mixtures where there are one or more solids present in the solution. You will see that in this lab we only have one solid combined with water, and through evaporation we are going to remove the water from our solid. Let's now proceed to talk about the experimental procedure. When it comes to the experimental procedure, as you can see in part 1, you're going to be observing some YouTube videos that are going to explain how to utilize a Bunsen burner and how to do a glass bending experiment. After you observe those videos, please go to the questions in the lab canvas quiz in order to understand the required information that you need to obtain from those videos. Remember that the lab canvas quiz is the only thing that you need to submit in order to get points for the lab. On part 2, it has to do with the separation of the mixture via physical methods. And in the next video, I will illustrate step by step how this part of the lab is performed.